Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on January 29, 2026, just yesterday. It introduces a new 68.5 billion parameter model called LongCat Flashlight that allocates over 30 billion parameters just to embeddings, successfully outperforming standard mixture of experts baselines. The paper is titled, Scaling Embeddings Outperforms Scaling Experts in Language Models. And as we'll see later, this architectural shift offers some really impressive gains in both inference speed and performance. Cat Flashlight are available, including simple Python code examples for using the model with the Transformers library, right away 29 words. Counting again, 1 on 2, Hugging 3 Face 4 the 5, 6, 8, 6 billion, 7 parameter 8, weights 9 for 10, LongCat 11, Flash 12, Light 13 or 14, available 15, including 16 simple, 17 Python 18 code, 19 examples 20 for 21, using 22 the 23 model 24, with 25 the 26 Transformers 27 library, 28 write 29 away, perfect. Wait, LongCat or LongCat? Text says LongCat Flashlight, I'll say LongCat. Figure 1 illustrates the core mechanism, the n-gram embedding layer. To compute the representation for the current token, C, the model actually combines two distinct pathways. On the left, the base embedding branch performs a standard lookup for the token itself. However, the heavy lifting happens in the n-gram embedding branch on the right. Here, the model looks at context sequences, like the 2-gram BC or the 3-gram AB circa. Instead of storing a massive dictionary of every possible phrase, it uses hash functions to map these sequences into compact subtables. These signals are then projected and averaged to form the final embedding. Figure 2 plots the scaling curves to determine the optimal timing for this integration. The horizontal axis tracks the sparsity ratio, meaning total parameters divided by activated ones, while the vertical axis shows the loss. If we look at the blue line, the standard mixture of experts baseline initially improves rapidly, but eventually hits diminishing returns. The green line illustrates that adding n-gram embeddings too early at low sparsity is ineffective and performs worse than the baseline. In contrast, the red line shows that introducing them at high sparsity successfully breaks that trend, achieving lower loss until the budget hits a saturation point. So, Figure 7 investigates how model geometry affects these gains. On the left in Chart A, the tall green bars show that wider models achieve the largest loss reduction. Conversely, the narrower models in blue and red barely improve or even regress on English validation tasks. Chart B on the right, however, reveals the opposite trend for depth. The shallow 10-layer model in blue sees a massive benefit, but as we add layers, the signal dilutes and that advantage shrinks. Alright, while Figure 7 analyzed the geometry, Table 1 here presents the concrete results for the final base model. It compares the proposed LongCat Flashlight on the right against a vanilla baseline on the left, with both trained on 1.3 trillion tokens. Looking at the reasoning section in the middle, we see significant jumps, like the score on BBH rising from about 38.5 to nearly 44. Similarly, down in the coding section, benchmarks like BigCode Bench improve noticeably, validating that allocating parameters to embeddings effectively boosts performance in complex domains. Well, Table 2 expands the scope to compare LongCat Flashlight against external state-of-the-art models like QN3 Next and Gemini 2.5 Flashlight. The most striking results appear in the agentic tool use section at the top. For instance, on the Tau 2 Telecom benchmark, the model achieves a score of nearly 73, drastically outperforming Gemini 2.5, which scores around 22. It also leads in the agentic coding section below that, where it hits 54.4% accuracy on SWE Bench. Wrapping up, two takeaways stand out. First, scaling embeddings offers a potent alternative to the standard mixture of experts approach, especially in high sparsity regimes. Second, by moving parameters into efficient lookup tables, the model gains significant speed without sacrificing reasoning capability. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.